I started my review career in 2000 on a small Greek site, writing pieces, one of which provided information on how to overclock a GPU, among other things. I took a long break, about 8 to 9 years, to obtain my bachelor's and PhD degrees, and I went full speed again in 2009, writing for the Greek site before I moved to Tech Power Up. Although I enrolled in almost any IT category, I liked power supplies more because there were so few proper PSU reviewers back in the day. Besides vast knowledge of electronics, if you wanted to go deep into this subject, you also needed proper equipment, which costs a lot. This pushed me to build my own PSU load tester, which I called Faganas. You can find Faganas' whole story in an old forum thread, look at the link in the video's description. To make a long story short, at first Faganas used switches to select the appropriate loads and later upgraded to relays, which I controlled through software I developed for this purpose. The software selected the appropriate resistors based on the chosen load, and it was smart enough to make combinations and use different resistor banks each time to stress them universally. The more you stress a resistor, the shorter its useful lifetime becomes. Soon enough, Faganas was replaced by electronic loads by array, and soon enough I built my first Chroma automatic test environment. In 2015, in addition to Tech Power Up, I also started freelancing, aka writing reviews for Tom's Hardware, which was on one of the largest IT sites at the time. I wrote some of my best pieces there, PSU's 101, a detailed look into power supplies, how we test power supply units. I will put the links of these articles to the video's description. The start of Cybenetics. Somewhere in 2016, I was so full of issues that I found in the 80+ methodology that I emailed them and offered to help improve it. People trusted 80+ certification levels, but the truth was that each methodology wasn't good enough to catch any serious issues that I usually found in my reviews. So I thought that I could lend them some parts of my methodology to improve it. I remember I got pissed when 80+ didn't even bother to reply to me, although I used my Tom's Hardware PSU reviewer capacity, which supposedly meant a lot back then. At first, I wrote an article about 80+ deficiencies. Then I decided to start my certification program, although I knew this would be tough, and many of my colleagues told me I would fail eventually. But this got me even more focused on my goal. In the Tom's Hardware article that they posted in January 2017, I had it delivered more than a month ago before this release date, I mentioned the following. The major downsides of the 80+ program can be broken into the following. Small number of measurements in order to classify PSU into one of its categories. The methodology allows for manufacturers to submit golden samples, very low ambient temperature at which the measurements are conducted. It doesn't measure the standby consumption, vampire power, which is essential to the European market, where all PSUs should comply with ERP Lot 6 and ERP Lot 3 directives. It doesn't take into account the 5SB rails efficiency. There is no clear mention of testing equipment. Moreover, the certification reports don't follow any ISO standard, which is the de facto when it comes to certification reports. 80+ doesn't effectively deal with fake efficiency badges. No noise testing scheme. I soon found more issues about 80+, which are even worse than the ones listed in my original article. After 80+ ignored my email about how I could help them improve their deficient methodology, I had only one way to proceed: create my own standard and a new company that would embrace it. This company was Cybenetics. I spent lots of time finding a suitable name, but I think I nailed that in the end. ETA Energy Certification. ETA is the 7th letter of the Greek alphabet. The efficiency of a PSU is typically denoted by the Greek letter small eta. This is why I decided to call our efficiency certification program ETA. Initially, I used A, B, C, E, and F ratings. Still, soon enough, a good friend of mine, Walter, told me that this certification will be dead because nobody would want to put on each box anything else but A, since even B in the US culture can be passed as fail. So after a year or so, I followed the metal ratings, titanium, platinum, gold, etc., with which people were already familiar. I just added a new top level, diamond, to provide a goal for all manufacturers and brands to improve the efficiency of their PSUs. Remember, certification is not a review and it's voluntary, meaning that you cannot pressure manufacturers or brands to send you samples for certification. So, including two manufacturers in the certification, especially the ones relative to performance, can lead you sideways and cause you to lose track of your goal, which in this case is to improve the PSU's efficiency. A certification's goal is not to compare units and judge their performance. This is for reviews, but to classify the PSUs in categories based on their performance in a specified area, efficiency or noise. This is why I didn't include ripple or load regulation or other performance aspects in the ETA certification scheme, but I only included the factors that affect a PSU's power consumption. In every ETA certification, we thoroughly test the PSU, taking every possible measurement, not only those related to efficiency. We also include most of our data in the corresponding reports so users have a complete picture of the PSU's performance. Moreover, we also check the protection features, which are of immense importance. When we find something we disapprove of, we inform the manufacturer to make the corresponding changes and return the sample for retesting. We even reduced our testing fee to half for any retest to help the manufacturers improve their products. Speaking of testing fees, I remember back in the day, some reviewers didn't like that we charge a fee for every test. There is no other way, since we have the equipment to buy and maintain, and of course people to pay, for who are the best in what they do. A laboratory's expenses are enormous, especially if you follow strict procedures. The calibration of all necessary equipment is also a heavy but necessary burden. While 80 Plus only considers 3 to 4 measuring points, I thought I should check way more and take the average as the PSU's efficiency score. This is easier said than done, but thanks to the software developed over the past 15 years, I can do pretty much everything with our testing equipment. I will describe the efficiency measurements procedure quoting parts of the PSU test protocol I wrote and listed on the Cybenetics site. Contrary to existing methodologies, which only take 3 or 4 measurements, we apply more than 1,450 load combinations in the DUT. The whole procedure lasts about 2.5 hours in total. The overall or average efficiency is the average of all measurements covering the PSU's entire operating range, except redundant PSUs where we take 2 to 100% of the PSU's operating range. This way, it is impossible for a manufacturer to tune its products to meet some specified load levels, since, in essence, we consider the efficiency levels under a higher number of different load combinations evenly spread throughout the entire load range. Besides efficiency, we also take voltage, ripple, power factor, noise and temperature measurements. In this code form, you will find the algorithm used to derive the load levels on the rails of an ATX 12V PSU. A simple algorithm is used for units with only 2 rails, main and standby. For the ETA efficiency certifications, we also take into account vampire power consumption and the standby rail's average efficiency. We measure efficiency on this rail per 0.5 amp stems up to its maximum current output, and the average of all measurements is the final efficiency result. Thus, we expect all PSUs to deliver over 70% average efficiency output on this rail, with this threshold set even higher for units that fall into the top categories of the ETA program. Using 1,450 different load combinations and then interpolating them to increase the number to 24,000 results, we have these graphs, which depict the PSU's entire efficiency map throughout all possible load combinations. As you can see, efficiency is in the 90 to 92% range in the 190 to 780 watt range, with the load on the minor rails not exceeding 110 watt. In addition to efficiency, we get similar graphs for load regulation and ripple suppression on all rails, and the raw data includes everything else from power factor readings to output temperature readings. Now that I have explained how we get our average efficiency readings, you can easily understand the difference between the Cybenetics test scheme and everything else, and why the Cybenetics scheme is superior. Note that we can easily increase the 1450 load combinations to 3000 or even more in the future if we deem this necessary. But rest assured that 1450 load combinations are more than enough. ATX version 3 and ATX version 3.1 pass program. Cybenetics is officially recognized by Intel starting from the ATX version 3 specification. This is one of the reasons that pushed Cybenetics to run even more tests on each PSU that it certifies to check if it meets all requirements that the ATX version 3 and version 3.1 specs list, including the transient response tests, or PSU power excursions as the ATX spec calls them, which can reach up to 200% of the PSU's maximum power for PSUs that are over 450 watt and have a 12 plus 4 pin connector. The transient response tests are only some of the tests that Cybenetics conducts to check for ATX version 3.x compliance. Others include PSU timings, DC power sequence, efficiency at 2% load, in-rush currents, load regulation, ripple suppression, turn-on overshoot, and more. In general, if the PSU doesn't meet any of the ATX version 3.x requirements, it doesn't get an ATX version 3.x pass badge. Cybenetics also evaluates redundant PSUs installed in servers operating around the clock. A redundant PSU consists of a mainframe with 2 or more power modules installed. If one fails, another module handles the load, so it continues its operation without issues. In most cases, the minor rails into a redundant PSU are generated by DC-DC converters installed on the mainframe, so the modules only need to deliver the main rail 12 volt and standby voltage 5 volt. Because all power modules of a redundant PSU are online continuously, there is no point in measuring vampire power. Moreover, unlike standard desktop systems, the systems that need redundant PSUs are destined for constant operation so that they won't operate for long periods in standby mode. In server PSUs, the 5HB rail isn't significant since its load and impact on efficiency is minimal compared to the overall load, so for the moment, at least, we won't consider the average 5HB efficiency as we do in ATX 12 volt PSUs. We consider the power consumption of cooling fans in the power modules. On the other hand, we don't consider the power consumption of any fan on the mainframe since we test the modules as standalone through a special testing fixture. We apply at least 1450 load combinations in the device under test. The overall efficiency and PF readings will be the average of all measurements covering 2% to 100% of the PSU's operational range. Lambda noise certification. Let's start first with the obvious question. What does the Lambda name stand for? Nothing in particular. I just wanted to use a Greek letter to name the Cybenetics sound level certifications, and I chose Lambda, which is the 11th letter of the Greek alphabet. When we started the Cybenetics test programs in 2017, there was no certification for noise output in IT parts, and currently only the Cybenetics Lambda exists. This is because it is complicated to find a way to measure PSU's output noise accurately and have a single number to describe it. I will quote again the PSU test protocol listed on the Cybenetics site to describe the whole procedure of how we take PSU noise measurements. As the efficiency measurements procedure mentioned, we apply at least 1450 different load combinations on the DUT rails while monitoring all vital data including the fan speed. With the fan speed range data in hand, we take noise measurements with as small intervals as possible with high accuracy and covering the entire range. For example, if the fan speed range is 400 to 2000 RPM, we take noise measurements per 50 RPM intervals. The noise measurements are taken in a hemianechoic chamber with a DUT switch off and each fan connected to an external power supply, applying the voltage required to achieve the desired fan speeds. Moreover, the fan speed is continuously monitored by a tachometer. This way, we can eliminate third-party noises, including the noise of electronic loads. We make a table with the fan speed in RPM and the corresponding noise at that speed. Our software then uses this table to analyze all data gathered during the load test and assigns a decibel value to each fan speed value. Once we have a dBA value for each of the tests we conducted with multiple load combinations, we convert the dBA values to SPL to average them, and once this is done, we reverse the outcome to dBA again. This procedure allows us to have a single number describing the DUT's average noise output with at least 1450 load combinations. According to this number, we tax the DUT into one of the lambda categories. Besides the fan's noise, we also check for electronic noise, coil whine, during the PSU's load testing. The human ear is the best instrument to check for coil whine, especially if its owner is young. Thankfully, most of the cybernetics engineers are below 30 years old. How things go so far? If I told you that we had an easy going all these years, I would be lying. We had a very difficult start, although large brands like Corsair, Seasonic and Silverstone supported us from the first day. Going against the popular certification but deeply flawed scheme like 80+, which had the monopoly for so many years, wasn't easy. We coped by offering way more and doing tons of free work during the first years of operation until all brands and manufacturers saw the true value of our work and our capabilities. Meanwhile, we kept investing in new equipment constantly while trying to find the best people to work for us. For more than 5 years, both me and Eri, my wife and co-founder of Cybenetics, didn't get a dime from Cybenetics. So we had to keep our day jobs and work all around the clock to keep up. I remember at some point in my life I was working at 3 IT sites, Cybenetics, and I also had my day job. Needless to say, there wasn't any free time to even breathe. In 2022, we made the huge step of moving the lab to Cyprus, our current place of operations. We hired more people whose CVs and faces can be checked on the corresponding Cybernetics page. We have a strong, competent team that focuses not only on PSUs but also on fan, chassis and cooling testing. I am also keenly interested in measuring power consumption on power-hungry IT parts, GPUs and CPUs. This is why I designed and implemented, with the help of Channel Well Technology, the Powernetics project, which is now the best tool for this job. On August 7, 2024, Corsair announced that it would stop using the 80+ certification scheme in favor of Cybernetics. This is a massive deal for Cybernetics when you have one of the largest IT brands that fully trust you. More than 60 brands, 64 so far, and manufacturers use our ratings since users ask for them, including First Player, Asus, Be Quiet, Corsair, Channel Well Technology, Cooler Master, Cougar, Enermax, FSP Technology, High Power, Inwin, King Power, Lian Li, Micronics, Montec, MSI, NGXT, Omen, HP, Pichao Gaming, Rachitech, Seasonic, Sarkun, Silverstone, Superflower, Thermaltake, XPG, and many more. Besides PSU certifications, Cybernetics also offers the following programs. Delta, chassis, measures the chassis noise damping performance. Phi, fan performance standard, cooling fans, measures the performance of cooling fans. Beta testing, we fully evaluate a wide range of products before they go into mass production, comparing them with similar spec products. We also find any possible issues that can affect performance and reliability. We already work with major brands to beta test PSUs, cooling solutions, fans and chassis. We have evaluated most branded and not only PSUs available today. Future goals. Our next big goal is to get the ISO 17025 and 17065 certifications, and we're working hard to achieve that. For those of you who don't know what these ISO certifications mean, ISO 17025 enables laboratories to demonstrate that they operate competently and generate valid results, promoting confidence in their work. 80 Plus doesn't possess this ISO. ISO 17065 Conformity Assessment requirements for bodies certifying products, processes and services. We will utilize it for our PSU, chassis and fence certifications. The ISO 17065 is also required to enter the Energy Star program. Please note that the 80 Plus doesn't have this ISO, but Energy Star set it as a requirement for Cybenetics. Cybenetics already operates under the above ISO guidelines. Before applying for them, you must use them for the specified period and follow their requirements. Cybenetics' ultimate goal is to replace obsolete certification ratings while constantly improving its methodologies and adapting them to any upcoming requirements and needs. It is a constant struggle to keep up and keep on improving, but this is a challenge that the Cybenetics team is more than happy to accept. Regarding the PSU's overall performance, Cybenetics has developed a highly sophisticated algorithm over the years, considering all vital performance and protection features of a PSU. This algorithm is used in the Hardware Buster's Best PSU article to classify all products based on their overall performance. As a certification agency, Cybenetics doesn't want to mix efficiency and noise with overall performance because these things might have some things in common, but also quite different. Although I have been a reviewer for over 24 years and electronics engineer for over 30 years, I can still tell the difference between a certification body and a review site. Performance numbers and comparison graphs belong to the latter, while a certification body's mission is to classify products in categories based on their performance in specified sections and reward manufacturers for their efforts. If you use too many factors for the certification process, for example, include performance numbers like ripple suppression or load regulation, you will end up with a complex rating system which will scare brands and manufacturers and be useless in the end since nobody will want to adopt it. In Cybenetics, we already check and provide all performance numbers which are included in the reports, but we only choose the relevant sections for our certifications. In case we notice that something is out of order, we don't proceed with the certification process, but we ask the manufacturer to fix the issues we spotted and provide new samples for evaluation. We want your support to continue in a more successful path.